Hello, geometry classes. Let's take a look at lesson 11.9, where we're working on finding scale factors of solids and using scale factors of solids to be able to predict surface area and volumes. Sample 1, we're looking at finding the scale factor of that solid figure A to the solid figure B. So what that means is that we're trying to find linear dimension and comparing it from the smaller rectangular prism to the larger rectangular prism. We are told the surface area of figure A is 180 inches squared. We're told the surface area of figure B is 245 inches squared. So what we're going to do is we're going to compare the surface area of A to B, and you'll see that I have written that idea here. And we know that the surface area is compared with the linear dimensions A squared to B squared. So let's go ahead and pull off the information for the surface area. Comparing A squared to B squared would be 180 over 245. The inches squared will cancel out, so we don't need to show that. Then we notice that we can reduce this fraction, so I'm going to divide both of these numbers by 5. So I'm dividing by 5 over 5, and A squared over B squared, the surface areas, compare 36 to 49. Well, we want to get it down to A over B. So this is a good time to take the square root. Once we have reduced this fraction, we notice that is a situation where we have perfect squares both in the numerator and in the denominator. That's helpful when we take the square root of A squared over B squared. That gives us what we want, A over B. That's our scale factor, A to B. And the square root of 36 is 6. The square root of 49 is 7. So sometimes it's easier to reduce the fraction first to reveal our perfect squares. If it's not a perfect square situation, of course you could use your calculator. But oftentimes in what we are practicing with in this lesson, we'll end up seeing either perfect squares or nice cubes that will easily simplify down to the scale factor we're looking for. Okay, so A to B is 6 to 7. Sample 2 is going to have us go in reverse. We're going to be given the scale factor of A to B, and that's going to be, again, a linear dimension. And then from that information, we are to figure out what the surface area and volume is of this big pyramid. We're also given the surface area and the volume of the small pyramid. So we're going to start by writing down the comparison A to B. That's our scale factor that's given to us. We can then figure out what A squared to B squared is. Square 1 and get 1. Square 2 and get 4. And then we can also figure out what A cubed to B cubed is. That would be 1 to the third over 2 to the third, 1 to 8. So we see how our linear dimensions compare, how our surface areas compare, and how our volumes compare. 1 to 2, 1 to 4, 1 to 8. All right, now we can use that information to answer the questions, what are the surface area and what are the volume of the large pyramid? The surface areas compare A squared to B squared, and we've already figured out here that the surface areas compare 1 to 4. So we'll take the smaller surface area, 144, and we'll compare it to the largest surface area. We'll call that x, and we'll solve for x. So using cross products, x times 1 is x, and 144 times 4 is 576. So the surface area of pyramid B would be 576 inches squared. Make sure you write down what it is that your units are. Since this is surface area, we will report it as inches squared. Our volumes compare A cubed to B cubed, so volume A to volume B is A cubed to B cubed, and we've already worked out that A cubed to B cubed in this case is 1 to 8. So 1 to 8 is equal to the volume of A we're given as 64, and we're trying to figure out the volume of B. We'll call that x. And again, we can use cross products very easily here. X times 1 is x. 8 times 64 gives us 512. And so that means that the volume B would be 512 inches cubed. And this is volume, so we'll need to make sure that the units reflect volume measurement inches cubed. Okay, that finishes our samples for lesson 11.9. Time for you to move on to the daily quiz, and we'll see you next time.